Welcome to Pomodoro Joe for Wednesday, April 5th, 2023. Today we're looking at LeetCode problem 2439, minimize maximum of array. It's a medium problem. So in this problem, we are given a zero-indexed array, nums, comprising n non-negative integers. In one operation, you can choose an integer I such that I is greater than or equal to 1 and less than n. And the number at index I is greater than 0. Okay, so we choose some random index in our array has to be greater than 1, and the value at that index has to be greater than 0. At this point, we decrease the num at index I by 1, so we subtract 1, and we increase the nums at index I minus 1 by 1. All right, so we can subtract 1 from the number that we're at, but we add 1 to the previous number. Now our goal is to return the minimum possible value of the maximum integer of nums after performing any number of operations. Okay, that is confusing. So let's take a look at the example here. So we have a number array 3716, and in one operation they choose the first index 7, and it looks like they subtract 1 from 7 and add 1 to 3. So we have 4 and 6. All right, and then they move on and they subtract 1 from the last number and add 1 to the second to last number. And then they go back to the first number and average them out to 5. And at the end, they get 5, 5, 2, 5, and the max number is 5. Wow, this is complicated. All right, I have a couple ideas, so we'll put 25 minutes on the Pomodoro timer and we will get started. So this one is tricky, but let's take a look at some of these numbers here. Actually, let's take a look at the rules. So if we look at the rules, we can choose any number from index 1 to the end. So we can't choose the very first number. It makes sense that we can't choose the number at index 0 because in order for this to work, we have to be able to increase the number at the index minus 1. And index 0 has no previous number. There is no 0 minus 1 in our array. I think that's going to be key. All right, so that means if we have some numbers, let's just make up some numbers here. We have 0. Well, actually, let's take a look at the second example they have, 10 and 1. So this means because we cannot choose index 0, we can only choose index 1 and above. We can choose index 1. It lets us decrease index 1 by 1, but that doesn't really help us because we have to increase the previous number by 1. So 10 goes up to 11. That doesn't help us. So one thing that does help us, though, at least in understanding, this shows us that our index 0 number, our very first number in our nums list, will never get smaller. So that very first number in our list is the smallest it will ever be. You can never get that number to be smaller than what it is at the start. It can increase, but it can never decrease. So that can be our default result. We can start our result at number index 0. So let's start with that. Okay, what else do we know about this? So if we had something like 10 and 1, well, there's nothing we can do about the 10, and changing our 1 isn't going to help us. So this is just going to be 10. But what if we had 10 and 100? Well, we could redistribute this. So we could drop our 100 down and increase our 10 to find something in the middle. Let's see, what would that be? Well, I think that would be whatever this delta is divided by 2, and then you add that to both sides, or subtract it from the 100 and add to 10. I think an easier way to do this, though, would just be to find the average. So if we just had 10 plus 100, that would be 110. Then you can divide that among the 2. So you can decrease this one by 45 to get 55. You can increase this one by 45 to get 55. And our answer would be 55. I think that works. Let's see if that extends out to our larger number, a larger set of numbers. So again, this we'd have 10, 100, and 1,000. Now if we took this 1,000, we want to get this 1,000 down as much as possible. So we'll redistribute that among the other two numbers. How do I redistribute that though? Well, I could find the average of 100 and 1,000. That might help, and then I redistribute that across these two. So 1,100 divided by 2, that would give us 550. So then we have 550 across these two, but we still have this 10 over here. That can absorb even more. So we could have the 10 absorb or merge with the 550, which would result in 560 divided by 2, which would be, oh man, that's going to be, I can't do the math in my head. Anyway, I think then when we have these two 50s, we still have this like 550 over here. We could redistribute again. So I think we just really need to get the average. I think this is like a running average. We just keep adding all of our numbers together and divide it among the number of spaces we have. Because we can always subtract some from future numbers and add to our previous numbers. All right. And what if we had something that was actually dropped down? What if we had like 1 here? Let's make it easier on ourselves and make it 3 so we can divide this evenly. Actually, this might not divide evenly. Let's make it 20. Will that divide evenly? Ah, nuts. Trying to think of something that will divide evenly here. 40. That'll divide evenly. Cool. So we've got 10, 100, and 40. If we took the average of these, that's 150 divided by 3. This would be 50 across the board. So this one we would increase by 10, which was, I don't think we can increase by 10. Yeah, we can't increase this one by more. This might be a problem. So we can't increase this one anymore. It's stuck at 40 because there's nothing ahead of it that we can decrease to make this one increase. Interesting. So we can't change this one. So we can only change 110. I mean, we could decrease 40, but I don't think that helps us here. So 110, we average those. We already did that, is 55. So we get 55, 55, and 40, and our answer would be 55. I think that's right. Okay, so I think what we need to do, yeah, okay. So here's what we do. We can take a running sum of all of our numbers, then find the average if we redistributed them across our various cells in our list here. Okay, I don't know if this is making any sense, but let's give this a try. Okay, so we're going to start our result as the very first value. I think that makes sense. And at the end, we will return our result. Now, I think we want to keep our running total. So I'll have a total, and we're going to start it at num0. Now we'll go through every index in our numbers. So do I even need the index, or can I just go through nums and numbers? No, I need to know the index because I need to know how many cells we can divide this value amongst. Okay, so for index in range, we're going to go from 1 to length nums because we've already handled index 0. Now our total will increase by nums at this index. We'll redistribute this total amongst all the number of cells that we have in the list so far. So at this point, we'll have 2 cells because we'll have gone through cell 0 and cell 1. So let's see, that means our, what do I call this? Cell value. Well, that's going to be equal to our total divided by, and we need to do a floating point divide here. We can't use an integer divide. And we'll divide this by I plus 1, because at index 0, we don't want to divide by 0 for sure. But when we have index 1, there are 2 elements in our array. So for example, if we had 10 and 100, when we're at 10, we have 0 plus 1, we divide it by 1, so that's going to just distribute 10 over one cell. If we have 100, we're going to be at index 1, but we have 2 cells, so that's index plus 1. So that's going to be 110 divided by 2, gives us 55. That's our, maybe I'll call this per cell value. There we go. So that's our per cell value. Now, because this is a floating point divide, I can't really use it directly because here we're only allowed to increase or decrease by increments of 1. So I need to take the largest of these values. So I need to take the ceiling of this. So essentially, if we have, I don't know, let's say 3.5, and we have 3 cells, we can redistribute 1 across 3 cells, but that doesn't give us enough because we've got 3.5 that we needed to redistribute. So we can put a 2 in one cell, and then 1 and 1 in 2 other cells. So, well, anyway, we'll take the ceiling. Okay, so that's going to give us our per cell value. Now our result, that's going to be the maximum of our current result, or this new per cell value. Okay, I think that might be it actually. I'm a little bit nervous about this. This math is a little bit tricky, so I might be getting something wrong, but I think this will work. Let's give it a shot. Let's see, this is nums. Wouldn't be a Pomodoro Joe video without some typos. And this is index. All right, let's try that. Okay, that works. Let's submit this and see if we can pass all the runtime checks. And we pass. We do okay. We beat 73% for runtime and 84% for memory. That is not too bad. Now, this is my attempt at an alternate approach. I didn't explain it very well, so I'm just going to rush through it. You can check out the source code in my GitHub, link in the description. Essentially, I imagine this whole thing, this array, as a series of chambers filled with water, and the value of at the index in the array is sort of the water level at that chamber. Now, the chambers have one-way valves, so a chamber can flow to the left, but it can't flow to the right. So any excess water in a chamber can redistribute to all the previous chambers. So this code reflects that kind of thinking. You can redistribute the values across all the previous chambers, but you cannot go into the future chambers. All right, check out the code. Maybe it'll make sense. Okay, so this does work. As despite my terrible explanation, this does work. I'm going to submit this and see how we do. And we beat 90% for runtime and 40%, well, 39% for memory. So it does do much better. Our previous one was 73%, so this does improve our score. Now we can go through and make some changes here, change some of these names, make it a little bit cleaner. That will probably help improve our score. I'll do it really quick just to see if we can get something higher than a 90%, but this isn't bad. So let's start with this. All right, this is ugly and I do not recommend writing code like this, but I'm trying to beat a score here. Okay, so we gained 2%. We're at 92% for runtime, 39% for memory. That 2% is totally not worth the obscurity that this creates. So that's it, I'm done. We've extended way past our time limit. Appreciate you sticking around. If you like this, please check out my other videos, subscribe, like, comment, all that stuff. All right, that is it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.